Urban agriculture.
Surya sir, have you joined? Hello. Yeah, Harjit ma'am, good afternoon. Harjit ma'am, good afternoon.
Good afternoon, sir.
And Surya sir has joined?
Yes, sir. Actually, I have informed Surya Prakash, sir. So I
Okay.
think he will be joined very soon, sir.
So as soon as he will join, we will start.
Okay, sir.
And our resource person has already joined.
Okay, sir.
Dr.
Thank
Dash,
you.
have you joined, sir? Yeah, Surya Prakash sir has joined. Fine. Antara, are you here?
Yes, sir.
Okay, okay. Good afternoon, Antara.
Good afternoon, sir. So, shall I start?
Surya sir has joined. Sir, good afternoon. Surya sir, am I audible? Surya sir, am I audible?
Yeah, you are audible.
Okay, sir. So, with your permission, shall we start?
Yes, please.
Thank you, sir. Okay. So, yeah, Antara, you may please.
Sure, sir. So, good afternoon to each one of you present today. It is a moment of extreme pleasure to welcome the guests who are present here to attend today's webinar. I am Antara Kundu, Project Executive SAIARD, and I'll be the host for your day. On behalf of the institution, I convey my regards to all the delegates, speakers, and the guests who have joined us, and for the and joining for the first day of this 3 days online capacity building program on coastal disaster risk reduction and resilience, jointly organized by National Institute of Disaster Management, Ministry of Home Affairs, Government of India, and South Asian Institute for Advanced Research and Development. I wish this seminar enlightens us all and provides us with approaches to deal with the problems of tomorrow. So, further making any delay, may I now request Dr. Bishil Choi Chaudhuri, Chairman SAIARD, to say a few words. Over to you, sir.
Thank you, Antara. Thank you to the honorable delegates, resource persons, and especially Professor Shugato Hajra, Professor of Jadavpur University, Dr. R. Thakur from the Odisha Space Application Center, and Dr. S.K. Dash, from senior scientist from NCCR, Ministry of Art, Science, and all my colleagues, and Professor Surya Prakash sir from NIDM, and our honorable past executive director of Manoj Bindal sir, and Harjit Kaur ma'am, from all the participants, those who have joined from the different corners for this capacity building program on the coastal disaster risk reduction and resilience, organized by SAIARD and NIDM. So on behalf of SAIARD, I heartily welcome to all of you and hope you know that this is our 7th program in collaboration with the NIDM, and we are from the very beginning of our institutions, we are mostly focusing regarding these kind of capacity building initiatives in different sectors, particularly in urban, river, and the disaster management sectors. And in this coastal risk reduction, you know that particularly I am from West Bengal, and the situation of West Bengal, even in other states also, those who are belongs in inside the coastal areas or near the coastal areas, what are the recent situations we are going through? Definitely our resource persons, those who have joined from, those who are the gemstones of the research in this but in this particle, and they will definitely share some evidence-based research activities to all of you, as that you may get the actual knowledge. And I will not let you inform about more because I'm not that in that particular field, but still we can observe as a social scientist researchers, we can observe that what is our future we are going through regarding this coastal risks, and what will be the consequences if we will not be able to aware about the recent trends of the coastal risk which we are going to face, and we have to take in whatever the precautions we have to take in. These all things within this 3 days event we will basically going to learn, and also we are going to learn the application of the modern technologies like the geospatial technology and other artificial intelligence like that technologies, which will support us in case of mitigation of this reduction of disaster sectors. And this program hopefully will definitely help you to get something new inputs about the disaster risk reduction, particularly in coastal hazard sectors, as well as, and in collaboration with NIDM and SAIARD, we are jointly working several capacity building initiatives. We have taken several capacity building initiatives in different hazard related, disaster related aspects. And I'm thankful to Dr. Surya Prakash sir that this is our hat trick of our program, through which we meet up and again we will collaborate with this platform, and help. Definitely our initiatives will help. We will try to our initiative will support you to energize your mind, energize your knowledge, efficiencies and all that. So once again, I would like to share my sincere thanks to all of you, and especially our honorable resource persons of today's session. And with this, I conclude my speech. Thank you, Antara. Over to you, please.
Thank you so much, sir. Now we have a special address by Professor Surya Prakash. Professor Surya Prakash is a doctorate in art sciences with a specialization in geohazards risk management. He's the head of the Geometeorological Risk Management Division and CBR and DRR and Cybersecurity Division, faculty in charge of specialized centers, Center for Hill Area Development, Center for Early Warning and Communication, Center for Coastal Disaster Risk Reduction and Resilience, Flood Monitoring Center and Emergency Operations Center, as well as coordinating faculty for 8 central ministries. Over to you, sir. Professor Surya Prakash, sir.
I think there is some problem. Am I clearly audible? Oh, I joined 2 times. Just give me 1 minute. Clearly. Hello.
Yes, hello, sir.
Yeah, am I audible?
Yeah, perfect.
Yes, sir, you are audible now.
Thank you. Thank you. Sorry, I couldn't see the screen there. First of all, let me welcome all. Good afternoon to everyone to this training program being held in collaboration with SAIARD, which is South Asian Institute for Advanced Research and Development. We are very happy that SAIARD joined with NIDM in order to undertake 3 days online training program on coastal disaster risk reduction and resilience. This theme is very important for us as the coastal areas have been adversely affected due to various reasons, be it the ill-planned developments or illegal occupation of the susceptible zones, or be it the changing climatic conditions which have brought emerging hazards into these areas. So there are various regions which have actually clubbed together to increase the severity, intensity, frequency, and distribution of different hazards into the coastal areas. We have several instances in the past which remind us of these coastal hazards. For example, I can recall the Indian Ocean tsunami, which took place on 26 December 2004, and also the various cyclones which have struck in the past, including the Philand cyclone, Spani cyclone, the Oki cyclone, or you can talk about the recent ones in terms of the Amphan, Nisarg, or Yas and Taute cyclones, which had affected our coastal belts quite a lot. Besides this, there have been instances of the coastal landslides and some reports on submarine landslides as well. And then these coastal areas, because of post-cyclonic heavy precipitation, has also suffered from the floods in the low-lying areas, as well as due to the river discharges from the hilly terrains towards the plain areas in the coastal zones. Despite the regulations and rules on coastal zones, these have not gone well in terms of the grassroots level benefits to the communities living in these areas. And this actually brings out or highlights us that the involvement and partnership with the communities living in those areas can only bring success in our efforts or endeavors towards disaster risk reduction and resilience. So therefore, it becomes very important that we share requisite necessary knowledge, information, ideas, experience, innovations with the communities and different stakeholders at the grassroots levels, so that they can take adequate, timely actions at the right place, at the right time, with the right people to attain our goal of the national policy on disaster management, which was released on 22nd October 2009, envisaging the aim towards zero casualty, disaster-free and resilient nation, and with a focus on developing a culture of risk assessment, prevention, mitigation, preparedness, and efficient response as well as recovery. So acting in a very proactive manner rather than being reactive, ad hoc and piecemeal manner. So now with these efforts, we are trying to enhance capacity of the human resources for mainstreaming and integrating the holistic proactive approach towards disaster risk reduction and resilience, along with development and changing climatic conditions, which are actually considered to be responsible for the increased risk in these areas. Lot of investments are being made in enhancing the infrastructure in these areas, which is also leading to higher level of risk in terms of socioeconomics. But on the other hand, we had also undertaken several good projects at the national level with the support from the World Bank on the coastal protection and resilient infrastructure. One of them, the most important, would be the National Cyclone Risk Mitigation Project, which have already passed through its 2 phases, and lot of contributions have been made in terms of making the infrastructure resilient against the cyclonic risks. On the other hand, these respective states, we have around 7 states which are affected by the coastal hazards. Their disaster management authorities, and also at the level of district level disaster management authorities, they have prepared their plans for disaster management, which also need to be actually properly updated, revised, and made dynamic as per the existing conditions or changing conditions and variabilities being accounted for. One of the important parameters which has been set way back in 2015 on from 14th to 18th of March was the Sendai framework for disaster risk reduction, in which we had fixed up the 4 priority actions in terms of understanding disaster risk, investing in disaster risk reduction and resilience, and strengthening disaster risk governance. The 4th one was build back better, and learning from the lessons given by the past disasters, and looking for the better opportunities. So we have been trying that. And on the other hand, the Sendai framework for disaster risk reduction also gave us 7 target points through which we can actually monitor our progress of the endeavors being made for risk reduction and resilience. That included the reduction in the number of casualties, reduction in the number of people affected by disasters, and also reduction in damages and losses to our infrastructure and the structures, and but particular focus on the educational and the health buildings, and then the strengthening of the collaborations between different countries and different partners, along with the national and local level strategies development and establishment of an effective, reliable, credible early warning system at all levels. So all these are very, very important steps that we are looking forward to. And hopefully our efforts with these kind of training programs, workshops, conferences, and webinars is likely to help us in achieving those targets, with the involvement and key actions to be taken by the respective stakeholders after the program. Geospatial technologies have contributed a lot when we are talking in terms of the regional variabilities or spatial attributes with the temporal variabilities and variations. So these have served quite well, and they also not only help in terms of mapping, monitoring, but also damage and loss assessments, and a very quick way. So the utilization of the state-of-art technologies and imbibing the principles of disaster management in all development sectors were part of the 10-point agenda on disaster risk reduction given by our Honorable Prime Minister subsequent to the Sendai Third World Conference during the first post-Sendai, I would say, Asia Ministerial Conference on Disaster Risk Reduction, which was held from 3rd to 5th of November 2016. So those 10 points we have to look into and follow up, which actually not only address the issues related to Sendai framework, but also the Paris Climate Agreement as well as the 17 Sustainable Development Goals. So there are a number of parameters, and we are happy to see that number of good resource persons, distinguished speakers are there in this 30 days program who will be actually elaborating so many of these aspects and dimensions of disaster management. And I would also urge participants to kindly consider the implementation of the key takeaways in their respective functional areas, geographical areas, and society. And the goal is that we should include all-inclusive approach and ecosystem approach. No one should be left behind. And COVID-19 over the past more than 2 years have taught us that if until and unless all are safe, we cannot be safe. So if I want to be safe, I have to make others learn and implement the best practices in disaster risk reduction and resilience. And these are some of the actions that should become an integral part of our lifestyles, as we say during this pandemics. Also, COVID appropriate behavior is to be adopted looking into the pandemic situation, which still is continuing and prevailing in our areas. With the invasion of the recent variant of concern, Omicron, from 2021 December onwards, we have still been facing the challenges of the COVID-19. And the Disaster Management Act, in fact, helped us quite a lot in dealing with that COVID-19 pandemic situation. Since December 2019, it was reported, and thereafter from March 2020 onwards, we started with the lockdown and various containment control mechanisms, and following the 3T, the tracing, testing, and treating, along with the vaccination, which came up in January 2021. And you know that how fast we have achieved our goals in terms of vaccinating our citizens and also achieving the targets in a very short period of time, making our people immune and resistant against the severe impacts of the disease. So no doubt, vaccination alone will not work until unless we follow the COVID appropriate behavior as well. So Honorable Prime Minister during October 2020 had also actually launched a campaign, public campaign for this. So many things have happened and we are following and continuing. But as Vivekanand ji has said, that we have to sustain this process and stop not till the goal is achieved. So journey is long. Our destination is zero casualty, disaster-free and resilient nation. There are a number of milestones that we will have to cover. And we started with way back in 1990 with IDNDR from 1st January 1990 onwards, when it was declared in December 1989. And followed by Yokohama Conference, then Hyogo Framework of Action, and currently the Sendai. So there are a number of steps the global level which have been taken up. And same way we have also worked on the national level with the establishment of a National Center on Disaster Management way back in March 1995. Then upgradation of this center to an institution, and then institution being notified as a statutory body under the Disaster Management Act 2005. And similarly, establishment of the disaster management authorities and disaster response forces at the state level, national level, as well as the state level. So number of attempts are being made, and journey is tough, but we need not be scared, but we should gather our courage and strength to meet the challenges and adopt to a better lifestyle in harmony with the nature. So if we take care of the nature, nature will also take care of us. It has provided us all the resources for our survival. So let's work out and see how best can we live in with happiness, peace, safety, healthy, and good quality life on an equitable, justifiable, and right-based manner with good fraternity. So I wish you all the best and hope we will continue this march towards our destination for disaster-free and resilient nation with zero casualty. So thank you very much for providing me this opportunity, and I wish all the best to the distinguished speakers and also to the delegates and the participants of this program. Thank you. Back to you.
Thank you so much, sir. So let's go for technical session today. On the technical session, at first we have a lecture by Professor Sugato Hajra. Dr. Sugato Hajra, a geologist by profession, is a professor of coastal zone management and former director of the School of Oceanographic Studies at Jadavpur University, India. He has done pioneering research on Sundarbans, climate change, its biophysical and social impacts. He has led several international and national level research projects on Sundarbans and coastal oceans and has more than 100 international publications, edited volumes, monographs to his credit. He has mentored over 30 PhD students. Dr. Hajra has been a member of the Indian Antarctic Expedition in the year 1996 to 1997. He is a recipient of the Gold Medal from Asiatic Society. He was a member of National Task Force for Bay of Bengal Large Marine Ecosystem, and he has been a member of the West Bengal State Coastal Zone Management Authority nominated by the Government of India. Today, he will be speaking on a topic of disaster risk reduction through sustainable development in Sundarbans. Over to you, Dr. Sugato Hajra.
Thank you very much. And thank you, SAIARD and NIGM. Can you hear me and see me?
Yes, sir. We can hear you and see you.
Okay. And see the presentation also, because that is the technical part. Can you see the presentation also?
Yes, sir.
Hello?
It is visible, sir.
Okay. Okay, great. So thank you all for allowing me to present the case of Sundarban in the 3-day seminar of coastal disaster risk reduction. And you all know that Sundarbans lying in the Indian part with around 5,000 kilometers square of mangrove forest and around 10,000 square kilometer of mangrove cleared areas are site of consecutive disasters for the last, say, 30, 40 years. Just now, the IMD has released that South 24 Parganas or the Sundarbans are the hotbed of cyclone landfalls. In the last 2 years, we have seen both Amphan and Yas in 2019, Bulbul, and like that. Uh, the cyclone return period has been calculated by IMD for severe cyclone to be 1.6 years, but we are getting faster, more frequency and faster cyclone because of the abnormal warming of the Bay of Bengal because of the climate change, as discussed by Dr. Surya. And coupled with that, we have an extreme high rate of sea level rise that when we started research, we were campaigning about the loss of islands from Sundarbans, but now the government of India has tabled their Minister of Earth Science report that yes, Diamond Harbour or Sundarban is having the highest rate of sea level rise in the country. That is 5.2 millimeter per year. That is measured up to from 1950 to 2000. And the third important disaster that we face, that is not the fast onset kind like a cyclone or sea level rise that 3 to 5 millimeter per year, but it is much faster than that. But it is actually a slow onset uh, because the erosion or the island loss is a slow process, and the rate is around 5.6 square kilometer area per year. In the last 20 years, we have lost around 110 square kilometer area only from the forest mangrove island. So I'll be opening up my discussion with this, that whether mangroves can save us, because we are unable to save the mangroves from this increasing high intensity disaster. So what will be the path? And as there are a lot of students and researchers, I must first distinguish between a hazard and a disaster, because we cannot manage a hazard like cyclone. We can predict about it, we can do early warning, but we cannot actually resist it. Or a tsunami. Now we can also give warning for tsunami, not like the 2005 one. But how then we can reduce the risk of that? Because the risk of hazard actually happens when the hazard is transformed into a disaster, when the hazard acts on a vulnerable population, that A and B two circles meet there, and that hazard circle and the vulnerable population, if they are together, then it lands up into a disaster. So the first approach will be of us to save the people from the increasing disaster, because that UNSDR slides that I have pasted in the bottom of it, it shows that the floods have increased in the last 2 decades, while the earthquakes are remaining same, more or less, not very high, but the number of droughts increased, extreme temperature event or heat waves, as we have observed in Delhi and Uttar Pradesh, increased, and there are increased number of storm events in the world. So all these climatic uh, disasters are happening in a much more high intensity and high frequency scale, which can be attributed to the climate change. And the other point that I want to make, that there is a definite relationship between the disaster risk reduction and development. Development, as we thought earlier, that it will be concrete embankment, or it will be big buildings, safe buildings, cities on the coastal areas, not the villages, vulnerable villages. So that was our initial idea. So, but we now finally realize that development can reduce the vulnerability of the people, definitely, like say embankment or cyclone shelters, or some risk reduction methods like cyclone warning and other things. These are development reducing the vulnerability, but making cities in vulnerable coastal areas and development in terms of multi-story building and putting a lot of people together can increase the risk of a different kind of disasters like earthquake, because a lot of people will die if a disaster strikes in a particular location, say, or not Calcutta. So there can be an inverse relationship between the disaster and development unless the development is well thought out, or the disaster can set back development, as we have seen in the past for the COVID is a biological disaster, and it has really eaten on our GDP, and we are struggling to recover. So it can hinder the development, or even a disaster, as a plan of our 2016 disaster management policy. We can think of build back better. If it is destroyed, then we can build a old city in a much more safer way, maybe flood proof Hyderabad, like that. So there are different dimensions of actions between the disasters and classical type of development. However, the new concept that Dr. Shura has touched upon is a sustainable development. The alternative way of development is a development that meets the need of the present without compromising the ability of the future generation to meet their own needs. Because in the last 50 years, probably we have developed at the cost of the environment. We have destroyed the forest. We have, harvested the ocean like anything. We have dumped all our pollutant load to the ocean. And finally, the nature is paying us back. We are unable to develop further unless we change this transfer of natural capital to finance capital. And in between, we can have social capital to be developed and to make the disaster development inclusive of nature as well as people. So social, environmental, and economic, these three things balanced together will actually guide the sustainable development way. And we'll be discussing today with the case of Sundarban, how these two processes of disaster risk reduction as well as sustainable development may converge. As mentioned by Dr. Surya, that though they are from 1992, the Rio conference, we adopted the agenda to build a global partnership for sustainable development. But finally, with Millennium Development Goal and other things in between, 2015 became a landmark year for multilateralism and international policy shaping with the adoption of several major agreements. And you may understand that it is not only the natural science and social science and environmental science, but politics has a definite role to play here. You may remember that the Paris Agreement for 2015 climate change agreement was signed not by Trump or George Bush, but by Obama. So you can see that there are policy shifts when the politics changes in a particular country, and the most prominent country of the world who are the major producers of these greenhouse gases and other things. So the Sendai framework of disaster risk reduction, also as a follow-up of the previous, disaster risk reduction frameworks, it came into action, the Hyogo framework, it came into action from 2015. And we have a multilateral financing agreement, and we have the Sustainable Development Summit, which adopted 17 sustainable development goals. So we'll see that what is that relationship between disaster risk reduction and the sustainable development goals. As mentioned earlier, the NDMA came up after finally India woke up to a big disaster like the Boxing Day tsunami, as mentioned earlier. Because in the decades for international disaster risk reductions, we didn't do much. Our first parliament resolution came up of making the Disaster Management Act in 2005 and defining what will be what will be called a disaster. This has now been fine-tuned in 2016, but a damage, degradation of environment is also considered as a disaster. That was a great idea, I think. Man-made cause or natural cause has been included. So I think that we have started developing our disaster resilience in the form of an act. But now, as we have distinguished between the hazard and a disaster, we may go through two further terms of vulnerability and risk. Uh, because the hazards can be many types. Geological hazards like earthquake, volcanic activity, all of these things happen in the coast also. I am not taking up at this particular this particular lecture. However, it can be slow as well as fast. Say erosion or subsidence. These are peculiar type of geological and quasi-geological hazards. The biological hazards can be there. It can be Minamata disease or the COVID, as mentioned earlier, because of virus or microorganism or bioactive substances. And there can be, as we are discussing more, the hydrometeorological hazards, the tropical cyclone, thunderstorm, hailstorm. We had hailstorm and lot of damage in MP and other areas. So tornadoes, blizzard, heavy snowfall, avalanche, coastal storm, surges, flash flood, drought, sea level rise. You can see the duration of a cyclone or a thunderstorm or an earthquake is different from the duration of sea level rise. So both fast and slow onset duration of flood and droughts are more than the thunderstorms. So like that, there can be different span of disaster happening, hazards. So how this can be turned into a disaster? This is a picture from Moshuni Island, not from a cyclonic surge inundation, but actually it is a high tide breaking the embankment. It is spring tide. So vulnerability of the people and the resources. Immediately you can look at that, okay, if these houses are mud houses, then will they survive cyclone or flood? If the houses are so low, because the altitude of Moshuni Island topographic height is 3.4 meters from the sea level. And you know the sea level is also varying. The islands are also subsiding. So you can understand the situation. And there are embankments, but this is the road where a lone woman is traveling. So the vulnerable people are the widows, are the women, are the dependent. So what are the causes of vulnerability of a community, coastal community? So that also becomes very important. Then comes the risk. So risk are actually a product of hazards and vulnerability. So this is the common area. And these we have discussed in our linking IPCC AR4 and AR5 framework in this paper that I have mentioned here with the DOI and other things. So this is the risk if we have to reduce in the coast. What do we reduce? Do we reduce the hazard or do we reduce the vulnerability? And what is the vulnerability composed of? Vulnerability composed of summation of, say, exposures and sensitivity of the system and adaptive capacity. If the adaptive capacity is more, your vulnerability is less. So we can actually, when we do risk assessment exercises, we have two options. Either we can go with the AR4 framework, which describes exposures as maximum temperature, minimum temperature, flood, cyclone, river and coastal erosion, everything as exposure. Then it takes up the sensitivity as population below 6 years, female population percentage, SC/ST population, that is a disadvantaged population, marginal workers, BPL household, no assets, no land, agricultural dependency, non-workers, kacha house, forest degradation, land conversion from, say, agriculture to aquaculture, like that. And adaptive capacity is a literacy rate, pakka house, road density, health institution, education institution, electricity, sanitation, safe drinking water, crop diversity. You can understand that if you have to reduce the risk, you have to reduce the vulnerability, and vulnerability is a product of, in the IPCC Air 5 framework, they have changed the exposure definition. They have changed population density, agriculture, dependency, fisheries, livestock under exposure. That is the people and their production under exposed to the hazards. And these cyclone, flood, and riverine coastal erosion, they are brought under hazards. And then we can actually reduce the vulnerability by increasing adaptive capacity and reducing these BPL household, no asset, no land. So that is working on the people, not on that. So this is a framework that we developed for risk assessment for Sundarban. We have calculated the erosion from different remote sensing sources, inundation from different SAIARD data, and now Sentinel data for YAS, and then cyclone hazard, flood hazard, and erosion hazard. Compounded together, we have developed a multi-hazard index. And then from the social vulnerability side, we have developed 16 indicators that we had assessed the social vulnerability index, and a product of that is given as a risk. So for entire Sundarban Delta, you can see the hazards are more on the coastal area, where vulnerability is not all some because of some fishing and tourism activity. The vulnerability might be less in the coastal areas, but it is very, very much inside poverty and multidimensional poverty. So a product of that will be the risk again along the borders, and this is the Sagar Island and Mosuni Island here. So the Sendai framework states that we should reduce the global disaster mortality, number of affected people, reduce the disaster economic losses in relation to that, and disruption of basic service will resist, disaster risk reduction strategies will take up, and increase the availability and access to multi-hazard early warning. So this is the disaster risk reduction activities that we can undertake in any coastal region, that, like I have shown, the hazard assessment, vulnerability assessment, and the risk assessment. Then we can take up mitigation measures like making embankments, structural and non-structural works, like land use planning and building codes, risk transfer methods like insurance, preparedness method like early warning system that we have developed in a much very strong way, and then emergency response and rehabilitation and recommendation area. So you can see that this map we have prepared just to assess that when people are talking about developing master plan, so what will be the master plan composed of? Are you thinking of the entire 151 of the villages of the biosphere reserve, or the repeated cyclonic inundation area like the pink color? So among the 151 villages, there are only 61 villages which has been repeatedly submerged. Then you can calculate, you can show that the sea level rise is affecting the rate of coastal erosion. This is from published paper. We can go for a village level hazard, vulnerability, and risk assessment. Even we can go up to household level if you allow us to do the, primary surveys with GPS. But the point is, how do you reduce the risk by structural mitigation? This was the embankment being built up at Mosuni Island, and a simple cyclonic surge has overtopped it. This is the earthen embankment which actually protects the 5 million population of Sundarban. This is the state of the earthen embankment. And this is the state of the, so you have shown the brick pitched embankment, earthen embankment, and this is after Amphan. the state of a concrete pitched embankment. So how do you save the islands? We are doing, say, so this is Yas surge warning from inquires. It didn't show much surge height in Sundarban areas, but because of the Coriolis force and the what we call the Ekman transfer, with the wind direction like that, definitely a big surge will come to Sundarban. It came actually at the time of high tide. And this is a situation after Yas at Ghodamar Island that thanks to the fact that the Panchayat house was built up as the Pakka house, so it has not fallen. So people have been rescued on the roof. And we have definitely evacuation plan, like we evacuated from Cyclone Phylline, we evacuated at the time of Yas cyclone. It was the largest ever evacuation in the world. The point is that early warning, preparedness, even emergency management like shelter facilities, evacuation, cannot actually reduce the risk unless we take care of the social vulnerability reduction measures. And it is you cannot reduce the number of female members or dependent or scheduled caste or tribe, but no literacy definitely you can act upon. Agricultural dependency definitely you can act upon by livelihood diversification. Number of marginal workers, definitely you can provide better works facilities. No assets, definitely you can improve. Household temporary structures, you can improve by making some PM Awas Yojana or Mukhya Mantri Awas Yojana. For Sundarban people, no room, we can have one more room. No ownership, they can have ownership house. Household drinking water source away, we can have safe drinking water to everywhere. That is our commitment. So why don't we provide it to Sundarban? And no electricity, now it is there in Sundarban. No sanitation, yes, it is a must that you have to do. So if you do all these things, that you don't use the fuel wood for health reasons, then you reduce the risk actually. And here lies the convergence with sustainable development goals. The first goal said no poverty by 2030, zero hunger by 2030, good health, at least a testing facility for COVID in Sundarban, quality education, that is the major stress. We have very strong education facility in Sundarban. But gender equality, can the women students study after class 8? So like that, a clean drinking water we provide. It is our commitment to the nation, to the UN. So we have to achieve all these and say reduce inequality, work facilities, decent work for all, and sustainable cities like Calcutta. I think it yields after 100 millimeter rain by waterlogging. If there is a high tide, we cannot clear it out. So, and this 13, 14, and 15, that's life below land, life below water, life on land, life below water, and climate action. So there are a lot of convergences that I am not going into the detail, but it is there. So if you want to achieve sustainable development goal, by doing the action will itself reduce the disaster risk in Sundarban. But the question of sustainability of man and mangroves of Sundarban comes from a different point. Whether you want to do all the conservation and disaster management by in situ development, or you can arrest and manage unsustainable land conversion, cyclone impact, saline floods, future conservation with mangroves. For that, will it be desirable to advocate future realignment of population by planned relocation and assisted migration? That, like, say, if you have a plumbing training institute in Sundarban, then the Adivasi youth can be trained there and they can act as a plumber as they have done in Odisha Kendrapara. So I have suggested to the West Bengal task force built after the cyclones to, if they have to have a mangrove to protect the embankment, then they have to shift at least 3,000 people little inland to allow the space for the embankment to be built up to 8-meter high, and mangroves front side or back side. But well, I mean, this has been proposed, and as we have tried to save the Sundarban from the land itself, This was my proposal to save it from the seaside. That is a kind of Bangladesh model of artificial oyster reef, whether that can be established, because this is a building with nature concept. And so that after some time, after some years, the mangroves will take place and we can arrest the siltation or erosion from the coast. And we have suggested that at these points, Digha, Tajpur, Mandarmoni, the East Medinipur, and Shagor, Moshuni, Bokkhali, and Deep Lot, and also to save the mangroves, the Bulcheri, Dalhousie, and Bhagadwani, because now mangroves need protection. So we suggested that because we are observed that a recent modeling paper that has been presented already, that even with a moderate RCP 4.5 climate model, I'm not going to the details of that, with say not even 1 meter rise by 2100, 0.72 meter rise, the island with subsidence rate of 2.5 millimeter, we lose major part of the so-called mangrove forest area of Sundarban. 45% will be lost. Can you afford that? Or you want to opt for ecosystem rejuvenation through the river rejuvenation, we can actually bring more sediment and fresh water, which will not only safeguard the island, but also save the people, and they can go for double cropping there. So these 5 rivers, if you take up Ichamoti, reconnect it, connecting Hooghly and Ichamoti with a very interesting river, Jamuna, reconnect Noai, you can see while going to the north Pradesh Pargana side, and rejuvenate the Vidyadhari and resurrect the Adi Ganga. This I have heard, and last year during the time of election, some agendas were coming up. So we have identified where are the blockages. You rejuvenate, the fresh water will come, it will bring prosperity to the delta as well as sediment to the delta front. So we can help the nature to build its own. And while doing so, while taking up this effort of sustainable development, I think we should not forget that we are working on the only tiger land, tiger mangrove of the world. So it is a World Heritage Site, and we have to think of the non-humans also. So I think with this convergence of disaster management, coastal disaster management, and sustainable development, these might be handled by different ministries, we can achieve the goal together by 2030. Thank you very much for the patient hearing.
Thank you so much, sir. If anyone from the audience have any query or any question, you can ask those, or you can write in the chat box as well.
Yes, I'm open to it. I think if they have questions, you can send it to me later also, and I can
Yes,
answer. You can go ahead with your
that.
schedule then.
Okay, sir. Sure. Thank you so much, sir.
Thank
Thank you so much for this. Thank you. Now we have a presentation by Dr. S.K. Das. Dr. S.K. Das is a senior scientist, NCCR, Ministry of Art Sciences, Government of. He holds a PhD in Image and Information Sciences for the topic named Two Direction Method on Atmospheric Correction in Ocean Color Algorithm, Direct Estimation of Surface Reflectance and Aerosol Optical Thickness from Graduate School of Science and Technology, Chiba University, Japan. His major programs and achievements are ecosystem modeling for Chilika Lagoon, SW Coast of India Coastal Vulnerability Study for Tamil Nadu Coast Chennai Flood Warming System. He has been awarded with Certificate of Merit for his outstanding contribution in the field of ocean science in the year 2015. He has uncountable number of publications in national and international journals and proceeding. Today, he'll be speaking on a topic of a glimpse of coastal hazard and vulnerability research in India. Over to you, Dr. S.K. Das.
Yeah, thank you, Antara. Good afternoon, everybody. Is it audible now?
Yes, sir, you are audible, sir.
Okay, I'm visible and audible as well, right? Okay.
Yes, sir.
Thank you, the organizers and the NIDM, for giving me opportunity to speak about the disaster risk reduction. Particularly, I was thinking to ask a question to Professor Hajra, but anyway, I know he was doing a tremendous work, particularly on the sake of DRR and as well as disaster management, particularly in coastal areas. So just I want to share my slide. Can you see my slide?
Not yet, sir.
Okay. Just 1 minute, 1 second. Okay, fine. I have to, yeah. Now it is okay?
Yes, sir. It is okay, sir. It is visible, sir.
Is it now full screen? Is it full
Yes,
screen
sir.
now?
Yes, sir. Yes, sir.
Okay, I think I just want to tell you that whoever during my presentation, if any questions are there, let them ask. Otherwise, they can write in the chat box. So myself, Dr. S.K. Das, and I working last so many years in this particularly National Center for Coastal Research, where we do all the scientific research on coastal related activities. So today I will talk about coastal hazard and vulnerability research point of view. As that workshop and particularly this training program is about the disaster risk reduction. So I think there is two different type of component you will find here. One is hazard, vulnerability, disaster one side. Other side your mitigation, DRRs and everything will be coming into picture. Where Professor Hajra was also telling that about how you to achieve all the SDGs in 2030. So what are the steps can be done? So that is another side. So today I will talk about the research part. So just for basic understanding, I think already Professor Hajra has told about vulnerability. I was thinking to tell the same thing. So, but I removed that slide because it was repetitive, looks like. So I just want to tell you that, in a coastal plain or in coastal areas, what actually comes. The first comes, coastal processes. How actually the interaction between the land and particularly the coastal area, land and the water, where the intertidal zones are there. So that means where low tide line and high tide lines will be there. How actually this coastal process actually works. And that we need to understand. So understanding, and because that will tell you the orientation of your coastline. So that will tell you now I think many of you might be Google that if you write, India is having a long coastline of 7,500. This is everybody, this is we are writing last, 1975 onwards. But still you know that whether the coastal length or whatever you say, coastal areas, is it 7,500 kilometers? So for that purpose, you have to understand how actually the coastal changes is happening over the time, because it is mostly happening, it is a natural process and as well as man-made activities. So that is most important to understand that. Second is that once it is happening, coastal change is happening means what? It is either erosion is happening or accretion is happening. So when the coastal erosion is happening, where it is a severe erosion is happening, suppose a cyclone comes. Mostly we know that Bay of Bengal is very predominant, particularly for the cyclone. And like mangroves and everything, though they are the bioshields, but still we feel sometimes, this some places, you might be seeing that there are a lot of erosions is happening. And there is a very much curious about that. But why it is happening? Is it natural or it is a man-made activities? It is both. So we have to thoroughly understand that what is actually coastal change. We also do the research on, how the sediment transport is happening. Actually, when the coastal change happening means what? When the sand is moving from one part to another part. So for that purpose, you have to know the sediment budget, particularly in particular area. So you have to know how is the sediment transport. For that, intense field data collection, your modeling will come into picture, your observation will come into picture. So all the management plans will be generally gradual. It will evolve. So if you talk about any SMP like shoreline management plan or CZMP, or slowly it is integrated because and ICZM plans. So all these plans slowly evolve based on this activity. And during this process also you have to consider climate change, you have to consider all the hazards which is particularly happening. Now, similar way, we also do the research particularly on coastal hazards, whether it is a tsunami, storm surge, oil spill, even biotype, any type of blooming is happening. So that type of things also we do, because this type of hazards will always give a direct impact to the society. When a tsunami happened, there are a lot of life and loss will happen. Storm surge activity, it is a regular phenomena in the country. Oil spills is again it is a regular phenomena in this country. So when it is happening and almost 30%, above 30% people are living in the coastline, and particularly predominantly city like Bombay, Chennai and Calcutta, these are the mostly coastal cities, urban cities are there evolving. We also found a lot of problems in there over that time. You might have seen that unprecedented floods are also coming, which we call as a coastal flooding. So that means slowly the hazards are permanent, that is there, but how much we are vulnerable, whether we are self-resilient or we have done anything enough for this vulnerability. So that's why coastal vulnerability study has been taken, and I think NIDM or all these sister concerned organizations, whoever is involved, I think many universities are also doing this. And climate change, tropical cyclone, tsunami, this is all also coming into picture. So ultimately what is happening, we know enough about coastal vulnerability or any vulnerability, but what is the outcome, what is the product you want to deliver? So you need the NDMA, or in this country particularly, for making disaster risk reduction tools. How best you can mitigate. Suppose a cyclone is coming, how best you can mitigate. How many hours before you need information that the cyclone is approaching in this direction. When tsunami is happening in a particularly almost in Sumatra way, so how much time it will take, how much time it is taking to reach Indian coast? How much disaster destruction it is going to be happening? That you should know. When the oil spill happens, due to modeling and everything, you can know that how much areas it is going to be affected, how much ecosystem is going to affect. So for that, we develop a lot of disaster risk reduction tools, which NCCR is always committed, and we almost work mostly this many activities: coastal processes, shoreline management, coastal hazards and vulnerability. I just want to tell you that we are now into a new domain of working on MSP, marine spatial planning, as a part of integrated ocean management, seawater quality monitoring, prediction of coastal water quality, risk assessment and development of standards, marine litter and microplastics. This 4 is coming under marine pollution umbrella, where we found a lot of biological disasters like pollution. Sometimes, is a bigger threat for the particular urban cities, because untreated sewage will be directly dumped into the ocean. Then, lot of advection process will be there, and, for that you need to be developed lot of, automatically you will get all this blooming is going to be happen. So when this blooming is going to be happening, this blooming sometimes it will become toxic to the environment. And that is definitely affecting to the ecosystem. So that's why we do a lot of ecosystem based services, and also we do a lot of activities in the coral based. And capacity building training also we take. I think this is about my organization, but I just want to tell you that what actually the disaster, particularly any type of disaster, how each component actually matters a lot. So what is happening when last 30 years, I think we are collecting this seawater quality monitoring throughout Indian coast. And from that, we try to get water quality index. And it is giving you the good information, whether it is the water quality is good or bad or moderate. Because every time when people go, the tourists go to the water, they don't know what is the water quality. And it is not like urban, like European countries or, America type of countries or developed nation like Japan and everything, where you will find people hardly bother about the water. But are you aware that, whether whatever water you want to go test, you want to touch it, is it really a good water quality? There are a lot of diseases is happening because the E. coli bacteria is predominantly more in our waters. So that statistics, how you will know? You can say that, it is only, so we need a series of systematic observation network. So NCCR is earlier it was called ICMM. So we were doing almost water quality observation, and from there, we make water quality index, and it is shared with Niti Aayog and MOSPI. So this is, and these are, at present, it is monitored up to 50 locations, and the data is shared, and that is actually a contribution towards the SDG. So SDG 14, life below the water, so that is also one contribution from our side, where we monitor water, plankton, microbial sediment, benthos, microbial. So all these things also we count, and also petroleum hydrocarbon also sometimes we measure based on the requirement. Apart from that, we also monitor a lot of bloomings when it is happening predominantly, very frequently. Mostly, you might have seen that coastal water quality is in many places it is called toxic blooms also will be formed. So that toxic blooms we study, and we try to tell that whether it is how is affecting to the secondary production and tertiary productions. So ultimately, this program will be this particular type of work research is helpful to know to understand the health of the coastal waters. So it is only observation part. We go collect the samples, and we analyze them, and we make an index. But apart from observation, what else is required? We need lot of indigenous system. We develop lot of water quality buoys. And these are the now 3 real-time buoys is almost ready. One now already 2 operational is there. One in Chennai on office, one is Puducherry. But now we are planning another 2, that is in Visakhapatnam, and one is in Lakshadweep. Another 2 is in pipeline. So this will be give you the online sensors will be there mostly. So it is a sensor based observations, and it will tell you the real time what is the water quality. And from that water quality, we try to forecast. Now, how we forecast? So we make different type of modeling approach. So we make observation, we make modeling, and based on modeling, we do lot of up to 5 days forecast we do. So mostly these all are hydroecological models. And these models are very high resolution models, and these models actually will give you the direct output, particularly what is the health of the coastal waters. And it is a very site specific area. It is not like that one whole coastline it will tell you the pocket wise, every pocket wise how is the water quality index. And this information will be shared in public information system and different government agencies. So this is all about water quality. Then after that, whenever there is an event happening, like a disaster, like oil spill is happening, or blooming is happening, or even normal case, where the pollution load is very high. So during that time, what is happening? The entire environment is changing. At that time, we also make an experiment-based observation called ecotoxicology, where you make different type of safe standard for different type of species. So toxicity biology experiments for different type of species will be observed, and it will be analyzed on the lab on a particularly similar condition. So from there we will try to know that what is the tolerance level actually for each species, because that is only we are consuming in our daily life. So this is also a scientific research and which we do, and I think this is the way it is also contributing to the SDG, because this information directly go to the bulletin of the MOSPI. Now another one program which I think I would like to highlight here, because disaster is coming into picture, we thinking, a long, because many disasters are very well understood. Whether it is tsunami, I think many people might be knowing nowadays, but prior to 2004, nobody knows. But now, one warning thing is coming, plastics. We don't know into, there was a paper, I think, it was everybody, I think, might be aware that in 2000 to 2050 there will be more plastic than the fish in the marine environment, which I think everybody is becoming aware. Now, for that purpose, we thought of, to make a national marine lit policy. And because NCCR always work with this policy, disaster related policies, and this is one policy where is on national marine litter policy, where we try to get the information actually which area is more. If you see throughout India, wherever there is a urbanization is more, there you will find a lot of debris. Correct. And from this debris, you will find a lot of litters. Not only that, recently we came to know that the water is the plastic actually don't disintegrate very easily. It will go into the as deep as possible, and it will be there for so many years, 1,000 years almost. So this is for that purpose only we made a different type of research. We make cruises, we make estimation. Now, some things I just want to tell you that in the coastal waters, when we measure, we found a lot of plastic related materials in the water and as well as in the beach. So we make, of course, awareness program that is the part of capacity building and training. But as a scientific point of view, we do all this analysis and everything. So one example just I want to show you here that over the Bay of Bengal, when we measure, you find that there are mostly it will be found in the sediment and as well as in the water. So in particular, if you see average 196 items there you will find in kg we found, and Chilika is a very small lagoon which is in Orissa, and Penna river is there in the South India. So where we found almost 480 items in Chilika Lagoon, and the Penna River we found 80. But otherwise it is more or less everywhere is equally distributed. Similarly, in water also we found almost in Krishna River is carrying lot of highest number of particles in the water, and as Kalingapatnam again in Andhra Pradesh, in the north of Andhra Pradesh, we found very less. But otherwise in most of the river banks we found, because that means all the garbage or whatever sewage is coming through the river to the open ocean, it comes, and plastic is mostly you can found in terms of items. So how best these things will be really helpful? That is also one of the study. So after that we do different type of coral activities, and that I think I will not discuss. So another part, I think many times we told that we do where I do actually the involved in this development DRR tools. One of the DRR tools is early warning system. So this is one case study to I think now to called integrated flood warning system. So this integrated flood warning system it was designed particularly for Chennai and as well as city like Mumbai. So these two cities are mostly heavily populated and dense populated, and as well as the industrial activities are more. And we saw that every monsoon it will scary the city. Every time we found that lot of inundation is happening. So that's why there was no warning system was earlier. So now we have developed one warning system, and based on weather, hydrological system and hydraulic system and hydrodynamic system of that particular area, because all these four only contribute this flooding. Whether it's a temporary flood or if it is 10 minutes, if it is flooding is there, you will find many low-lying areas are getting inundated. Why it is happening? People telling is easy that it is drainage network is not there, X is not there, Y is not there. But ultimately it will affect to the mitigations. The people are suffering. The administration has to come immediately. So for that, how best you can give the information. So for that purpose, there was a system which was badly required for the country. I think last year only we completed Mumbai. Previous to that year, we have done for Chennai. I think we are also now planning to go for Calcutta. So this is a system which mostly when we developed, we will start coordinating with the state government, and from there we will get all the data sets, and after that we will develop a model, and after that we will give the output, and that output will be shared with the government, so that they will do all the risk. So particularly in this system, you will find data assimilation module, flood module, inundation module, vulnerability will be there, risk module will be there, and as well as dissemination will be there. So all these things, end-to-end tool will be helpful to understand the flooding. Then another part, I think I want to tell you that regarding this shoreline mapping and coastal protection, because this is also my interest, because this is also will tell you the coastal vulnerability. Because when you talk about vulnerability, we think it is pertaining to, whether it is pertaining to only one hazard, or it is a series of hazard, or it is a long term. What? Actually, it is a combination of everything. As you know, it is you cannot say that in a coastline, a hutch, a pakka house and kacha house both are there, but a cyclone when is approaching, you know that there is a high vulnerable in a pakka house, sorry, kacha house. So what is happening during that time? What is happening when it is? Suppose imagine there is no people are living in that hut, mud, though it is made of mud, but there is nobody staying in that. Whereas in a pakka house, you will find lot of people are living. If the wind speed will be more, it will give a major disaster to the structure. But whereas though it is a small kacha house, but it will not affect anything. Anyway, that will be washed away, but it will not happen. Now you will ask me which one is more vulnerable, whether pakka house is more vulnerable or kacha house is more vulnerable. Depending upon the situation, depending upon the population, depending upon a lot of parameters to that. So social to environment, all these things are coming. That's why Dr. Hajra is also telling, Professor Hajra also telling social vulnerability is coming into picture. So all these things will be taken into that. And one of the biggest thing that in our coastline is that erosion. Erosion is happening frequently. It is happening many places. So for that, there are a lot of preventive measures though we're taking care. But why it happens, we need to understand that. So for that purpose, we have a database. You need to understand that how frequent it is happening. It is happening because a cyclone when comes, it is happening because of a cyclone period, or it is again, the beach is bounced back. That means if it is a beach is bounced back, you cannot say that it is erosion site. It is happening for a temporary. So eroding beach, accreting beach, stable beach, all these things will coming into picture. So you have to understand that why. But sometimes, this will lead to a lot of complications. Like one small example, I just want to show you here. One Pulicat Lake, I think picture you can see here. This Pulicat Lake, it is just in between Andhra Pradesh border and Tamil Nadu border. Now there is a I think everybody might be knowing about, there is Sriharikota in ISRO, where satellite launching pad is also there. So there is a problem in this, is very quite evident because of this sediment transportation, this eroding beach. It is having a highly eroding, sometimes highly eroding, and sometimes this because of erosion, the beach is actually getting closed. So sometimes beach is closed, sometimes beach will be opened by automatically. So all these things is happening seasonal. But as of now, when it is eroding, it is a entire area, entire lake. You will find a lot of fresh water into this. But the beaches will be closed. You will not find even a single exchange between water between the lake and as well as in the open ocean. And that will having a drastic impact on the ecosystem of the lake. and the salinity, the evaporation rate, all these things becoming high. So one time, so that's why this understanding of the shoreline map and coastal protections measures are much more, very much required for the country to understand this. And also when we do, we also take all this IPCC, AR5, AR4, okay, whatever things is available, that things we took. We took also the evidences of the sea level rise. Because over the time you know that when you are talking about 2100, what will be the scenario, that also you have to tell them. Because day by day the sea level is increasing. That is quite evident. And that things also when you have to consider when you are doing modeling or mapping. So that based on that you can make a structure. Because resilient, when we are talking about, because our as per Sendai frameworks, it is also highlighting, not only the protecting to the people, we also should protect the structures. Because that is a huge loss compared to the, even sometimes to the, as per the, compared to the public. Because when every year when the disaster comes in a particular cyclone cross, though our because of the accurate track prediction, whatever you say, or whatever our dissemination, though we manage to control our lives, but we are unable to control to manage our damage, particularly in the structures is concerned. So how, so that also depend upon country's economy, right? So that's why we need to address these things. So that's why we do a lot of activities, sediment transport, loss, gain, pocket wise we do, and we make. The last one is that I want to tell you, just another 2-3 minutes. We want to walk both India planning procedures and policies. Recently, just 1 year back, we started one program called Marine Spatial Planning, because Ministry of Earth Sciences has been under bigger umbrella. We are committed to do blue economy and contribution towards the SDG 14, like below the water. And so for that purpose, it is one of the component of blue economy called development of marine spatial planning. So marine spatial planning is different than ICZM planning, because at present everybody knows about CRZ, land use planning, but it is something little bit different. That means it is the extent of ICZM planning. Your territory will be little bit extended. So just to inform, just to tell you that if you take a beach particularly, you know that there is a land use planning beyond 500 meter and everything, and there is a existing CRZ is almost there, ICZM planning. And this ICZM planning is up to their intertidal zone and as well as up to 500 meter, where the tidal influence will be there. And inside the sea, you will having a almost 12 nautical miles. What are the different sectors will be coming into picture, or conflict? Everything will be consideration. You need a policy where you will easily demarcate your CRZs. So all these things are established in particular in India. But beyond that, what is else? After 12 nautical mile, we don't know. Because the EEZ is almost 200 kilometers. So for that, we need to extend our thing, because lot of potential development, everything depend on this. That's why the blue economy will coming into picture, where we need to take this, because that will affect to the entire the livelihood of the coastal areas. So as per the United Nations, there are clearly, United Nations framework. The difference was actually very clearly objective were defined, and we need to develop now MSP for location specific, with taking into consideration of conflicts, and which will tell you the growth of ocean economy or blue economy. So how we do actually when you start, where you start, how you do actually. First, we will start with the stakeholders. We take all the stakeholders at a particular site. As it is a site specific, you have to first consider a site. A site means it is maybe a state or a union territory or a small pocket. So where you take all the state governments and all the stakeholders particularly, then you define what you want to do, which area, what is your vision and goal. First you have to define that. MSP will be the underground, but still underground, what sector you want to do, that you have to clearly define. That is called vision and goals. Then after that you collect the data, You make the analyze the interrelationships, impact, conflict, everything. Then you prepare the MSP, then you implement the MSP, then after that you monitor and evaluate. So for that it is will be mostly field data observation, modeling, mapping, all special analysis tools, GIS based tools will be useful. All these parameters of different sectors like oceanographic parameter, economic sector, biological, habitat parameters, your ecological sensitive areas will come into picture here. Socio-economic data will come into here. So all these things will come into this particular domain, and you have to analyze this and you can achieve the success. I think this is all about, I think, a lot of work, particularly pertaining to the disaster management. And we also coordinate with MOFCC, MOH, NDMA, CPCV, and water resources, and all these things. Inter-ministry we work, and international collaborations also there. So mostly state government, when we do each program or each site-wise, state disaster management authority mostly will come into the picture, and all these IPCC bodies, these pollution control bodies will be there, and so we close to close one to hand one we generally work and do. And capacity building, of course, like this type of small training programs with a particular subject oriented training programs also we give. Thank you.
Thank you so much. If any of the participants have any question, you can raise that.
Hello, sir.
Yeah.
Yeah, myself, Dr. Rakesh Ranjan Thakur from Odisha Space Application Center. So actually, you are you are doing a lot of things in related to coastal issue. So after that, sir, I would like to have some discussion with you regarding this coastal issue.
Yeah,
So
no problem.
I would like to get your contact number and
Yeah,
email
I will
ID.
share my, I'm now sharing my email address. You can write to me, okay,
Yeah.
regarding anything related scientific aspect, if anything, if you want, or any clarifications or anything, such type of training programs or anything you want to do it in Odisha also, please let me know that, so that we will definitely use.
Yeah,
Okay,
okay, sir. Thank you very
thank
much, sir.
you.
Yeah.
Okay. Thank you so much, sir. Thank you for your time. Okay. So our
Thank
next
you.
speaker is Dr. Rakesh Ranjan. Yes, sir. Thank you so much, sir. Dr. Rakesh Ranjan Thakur is a scientist in Odisha Space Application Center, Science and Technology Department, Government of Odisha. He holds a PhD in remote sensing and geoinformatics from MDS University, Ajmer, Rajasthan, in School of Space Science. His research interests are coastal geomorphology, coastal zone management plan, natural resource management, biodiversity and conservation, coastal ecosystem, mangrove species donation, environmental impact assessment, watershed management, sustainable development studies, coastal vulnerability, coastal morphometry, wetland studies, remote sensing, geospatial technology, digital image processing, geography, etc. He has numerous number of publications in national and international journals, reviewed research paper and book chapters. He has attended several workshops, seminars, etc. Today, he'll be speaking on the topic of coastal applications using geospatial technology. Over to you, sir. Over to you, Dr. Rakesh Thakur.
Yeah. Having some issue here. Just a minute.
Yes, sure, sir.
To present now, it is not getting.
Yes, sir.
It is not coming actually. Some issues there.
So you select the present now option, select the screen, whichever, whatever you want to share, and then share your screen, sir.
First of all, I have to select present now. Then your entire screen. Then a window and a tab is there.
So you want to share your screen, so select your screen, sir.
Yeah, I'm selecting the entire screen.
So
Dr.
have you
Thakur,
like
Yeah.
opened your present?
first you
Yes.
first you open your PowerPoint presentation on desktop,
Yeah, it is open.
and now you go to the present share screen mode, present now mode.
Yeah, present now is there.
After that, you may go to the window.
A window is there, na?
Now you may find your PPT here.
Yeah, now I got it.
Okay, thank you.
Yeah, whether it is now it is visible, na? Hello.
Yeah, yeah.
Okay,
No, sir, it is
yeah,
not visible, sir.
it is not visible. Just a minute.
No, sir,
I'm
it is visible,
Yes,
trying
sir.
yes,
it once.
We can
it is
see.
visible.
It is visible, sir.
Visible.
Yeah, is it visible?
It's coming.
Hello.
Yeah, visible.
It's coming, na? Okay, fine. So, myself, Dr. Rakesh Thakur, and I'm working in Odisha Space Science Center, Bhubaneswar. First of all, I would like to thank NIDM and SAIARD for giving me an opportunity to deliver my lecture on the topic that is coastal application using geospatial technology. So, actually, I was attending the previous speakers lecture, and they were actually coastal pioneer, I can tell, like Dr. Professor S. Hazra and Dr. S. Kidas. They both have taught a very informative way, and different aspect of coastal issue have been covered by them, like coastal processes, coastal vulnerability, water quality related issue, then shoreline changes. Then also Dr. Das, he has covered CRZ issue. So my lecture is basically uh, it is like it is not for the coastal expert or coastal pioneer people, those who are very initial, they are working on coast. This lecture is going to be very beneficial for them. So here, these are the key points that I am going to discuss in this particular lecture. That I am going to have some brief discussion about geoinformatics, its concept, and also uses about remote sensing and GIS. Then we will have some discussion regarding CRZ, that is coastal regulation zone, and some burning issues related to coast. Then I'll be focusing about some coastal disaster. Then I will be sharing some of my expertise and experience in particular in Odisha coast, some cases study that I'm going to share with you people. So here, in a very simple way, now geoinformatics. Geo means earth, and informatics like study of information processing. That means we are studying the information about the earth terrain features. So in remote sensing or geoinformatics, this is nothing but an art or science or technology that deals with how to acquire and storage and processing the different information about the earth features. And now in this particular picture, you can see in the left hand side, this is the natural things are there. You can see flora, fauna, these are self-regulated, but in the right hand side, you can see these are managed. This is not self-control, it is managed by us, by these human beings. So nowadays, we can feel that there is an increasing of conflict between the self-regulated and managed world. That means this natural and man-made world, there is a conflict. Conflict is going on it is increasing day by day. So, in other words, we live in a changing world. Here now, you all know that there is a explosion in population. There is a urbanization is going on. Globalization is there. So, uh, we can say that there is an increasingly complex and challenging, and it's also crowded. So nowadays, this is the need of the hour. That means the geoinformation technology, it is very useful in order to deal with all these issue, the current issue.
Sorry to interrupt you, sir.
Yeah.
Hello. Sorry to interrupt you, sir. Your slide is not moving.
No, it is moving.
Okay.
Now whether it is visible to you, this one. Hello.
So it is stuck in the
Okay.
slide, stuck in the first slide, sir. Which slide you are sharing right now?
See, now I am in my fourth slide.
But sir, we can see
No,
the
sir. That's
slide
not
on
moving.
the first slide.
One. Yes. Right.
Now, okay. Okay, which slide now you are able to see?
Now we can see the fourth slide, sir. Slide 4.
We live in two worlds. This one, na?
Yes, sir.
Okay. Then, yeah. Now, I think you are able to see the this slide. That is to meet these challenges. Is it visible to all of you?
Yes, sir. Yes,
No,
sir.
sir. It
Okay.
is still in the.
It is there, na? It is visible. Then, should I continue?
No, no, no. We live in two worlds. This slide is visible. And can you,
Uh,
sir, on this presentation mode?
yeah, it is in presentation mode. Now it is visible to you. Hello.
Yes, sir. In other words, we live in a changing world. This
Uh,
slide is visible currently.
but I have already changed to the next slide. That is to meet these challenges. Whether it is there,
No,
I,
sir. We
I
cannot see that, sir.
I think it is taking some time to get changed, but I don't know what's the issue. From here in my, it is changing very easily, but I don't know why it is not visible to you people. Okay, which one is there right now? In other words, we live in a changing world.
Yes, sir.
Okay, then I'm changing to the next slide. Is it there to meet these challenges?
No, sir. It's still the fifth slide, sir. In other words.
Uh,
Yes, sir. Now we can see to meet these challenges,
okay,
sir.
okay. Actually, I've stopped that slideshow. I think it is visible to you now. Okay,
Yes,
so
sir.
here you can see that as I told that there is a challenges and we have to solve this issue. And in this issue, now you can see that we have to we have to know the better how to represent our earth features and how to understand it and how to manage, and also we have to communicate it. So in order to uh, get this, we have to go through some evolving system, like we have to measure the wall, we have to monitor it, how it is changing, then we have to use some model, some planning, then some decision can be taken. So in order to meet all these issue, the geoinformatics, it plays a very vital role. Okay, so here now this slide is visible. I think in my each slide I have to ask this.
Yes, sir. The
Yeah.
what is GIS, sir?
Okay.
Yes, sir. This
Yeah,
slide is
fine.
visible, sir.
Yeah. In the top you can see what is GIS. GIS is nothing but it is a geographic information system. So why I have taken this slide, because we need to understand that what is GIS and why the use of GIS is very vital in order to study the coastal process, and in order to make some changes, or in order to take some suitable decision in a coastal issue. So in GIS, actually, you can see that some people, software, data, process, hardware, these are some parts of GIS. Okay. And in a very GIS, as why GIS or geoinformatics is very important, because it is a convergence of a lot of technology. Like you can see remote sensing is there, environment is there, computer science, hydrology, ecology, etc. That means nowadays GIS is used in almost all department, and in all technology are going to be convergent in GIS. Okay, so here very informatics session is there. Like in GIS, it is possible to have some complex data modeling. We can integrate, we can have visualize the data, we can have some model, we can have interactive mapping. Okay, so if we are not in a background of geoinformatics or GIS, then also now it is possible that we can have some basic knowledge, and also we can apply in our own domain. Okay, so these are some 2 to 4 slides. They are basically on GIS and geoinformatics. Now I will be focusing on some coastal issue, and nowadays, as my previous speaker Dr. Das also told that CRZ, that is Coastal Regulation Zone, it plays a very important role, because as you know that coast is very dynamic, and coastal environment is very fragile in nature, and nowadays it is very prone to different man-made hazards and different natural hazards. So the government of India, they came with some regulation. Okay, so some regulation are there, and these regulation are very important to control the the activities that is going to be taken place in the coastal area. Here, coastal zone, it is a meeting point of your marine water and our land mass. Here, I can go for this Clark 1992, or some definition are there. Here, coastal erosion zone includes coastal water, tidal wetlands, and adjacent shoreland, which are strongly influenced by marine waters and vice versa. Okay, here in this diagram, you can see that CRZ, it is actually divided into 4 types. 4 subtypes are there. CRZ 1, 2, 3, 4. In one, what happens? Most of the mangroves area or ecologically sensitive area, these area are very sensitive, and these area comes under CRZ 1 category. Okay, and in CRZ 2 category, any urban designated area, like in Odisha, you might have knowing about the Puri Jagannath temple is there. So these area are coming under CRZ 2. Okay, and Paradip area is also there. So and CRZ 4, CRZ 4A and B is there. 4A means from the coastline up to 12 nautical miles. In the here you can see this area are coming under CRZ 4A, and here you can see the creek area or the riverine water area, they are coming under CRZ 4B. Okay, so this picture actually belongs to CRZ Coastal Regulation Zone 2011, and now CRZ 2019 have been completed in officially, but it is not coming to the public domain. It will be coming in a very quick session. Okay, here in the next slide, now it is visual, na? It is changing.
Yes, sir, it is changing, sir.
Okay, so here what I told in my previous slide, that here you can see the territorial sea area is there, and here is the land mass is there. So CRZ extend up to 500 meter in the coastal area, and it extend up to 12 nautical miles in the sea water. Okay, here in this slide, now it is visual. I think in every slide I have to ask this. Is it very visual? Hello?
Yes,
Yes,
sir.
sir. Yes,
It is
Yeah.
visual, sir.
Yes, sir. Yes.
Yeah.
Yes,
Okay.
sir.
In this diagram, you can have a better knowledge about the different classes of CRZ. Here you can see from LTL to 12 nautical miles in the seaside, we consider it as CRZ. and here in from STL, that is high tide line, from STL to 500 meters in the land mass, it is considered as CRZ 3 actually. And here when we are a river is there, a river is flowing to the sea, and in the river area, here suppose the width of the river is more than 100 meters. Here you can see it is 150 meters. Then the CRZ will be 100 meter. Okay, it is based on CRZ 2011 2011 CRZ notification. It is there, but here you can see the width of the river is very less, that is 50 meters. Then the CRZ buffer will be 50 meters only. And another thing is there. Now you have you may have some question that to which extent it is there. Now answer is that it will be extended for 5 ppd. 5 ppd salary means 5 particles per thousand. Up to this, actually we are getting this from the your pollution control board, and suppose here it ends from here, there is less than 5 ppt, then that area is going to be termed as the outline of CRZ. Okay, here then now as I told that the coastal area, some issue is there. Is it visible now?
Yes, sir, the coast issues.
Just a minute. Yeah, the coast issue. Here, you know that nowadays more than 40% of world population, they are staying within 100 kilometers from the coast. So the coast is facing a lot of environmental issues, like coastal infrastructure is going on very rapidly, coastal sewage is there, dwelling activity is there, coastal mining is there. So ultimately the coast is facing a lot of environmental issue. Okay. Okay. Here one example is one coastal hazard. It is a random click. Here you can see that due to the rise in sea level, this particular monuments, it is submerging. So this is one adverse effect of I mean coastal hazard. And now here you can see some biodiversity of mangrove swamps along the Odisha coast. Actually, I have taken this. Here you can see some flora, fauna are there. So these all the flora and fauna, they are actually in danger due to the coastal issues. Okay. Now in this particular slide, it is very informative slide. Here you can see the total coast of India. Now these are some example of different I can say different issues that is being faced by the Indian coast, like coastal erosion is happening in so many places. Then there is a degradation of mangrove species, and like Odisha and West Bengal, these states are facing the cyclone in a very frequently they are facing. So then coastal mining is there, coastal construction is going on. So here you can see from in both Bay of Bengal and Arabian Sea, all the coastal states, they are facing a lot of issue. So these issue can be solved out by to a particular extent by using geospatial technology. Okay, so by using geospatial technology like remote sensing and geoinformatics, we are in a position to have some very high resolution satellite data, and also we are having data in a temporal basis, so we can know that like suppose recently Jawaz cyclone hit our your Odisha and West Bengal coast. So before that, we are in a position to know that no, this is the path of the your cyclone is there, and it is going to hit so and so area. So before that, we are going to have some planning, and we can prepare ourselves. Okay, So we can monitor it, and after the cyclone, we can go for some damage assessment also. These things can be undertaken by using geospatial technology. So here you can see that monitoring and modeling, different we can have some modeling like coastal zone information system. We can have some shoreline change mapping. Some we can go for some vulnerability study, tsunami study, coastal pollution, and many more. Okay, so based on our expertise and based on our need also, we can have some planning by using geospatial technology. Okay, so next here you can see, like as earlier I told that my lecture is basically it is meant for the layman or those who are starting their career in geoinformatics. That's why I have included these 2 or 3 slides that includes some interpretation keys, how it one intertidal mudflat look like in a particular satellite image. Here you can see this is the ITZ intertidal zone, and here you can see the real field photograph. Okay, this is one interpretation keys. Another one is like high tidal mudflat with salt intrusion. Here you can see this cyan color light, but in this particular field photograph, you can see these are the salt intrusion area there. Okay, another one is shoreline delineation. High tide line is considered as the shoreline. Here you can see that the permanent vegetation is considered as the STL line. And now one geomorphological features is there, like bomb is there. Now this area is termed as the STL line. Here some man-made construction are there, seawall is there. So this area is going to be the STL. And sand dunes are there. They are going to be the your STL. Then landward boundary of mangrove. Okay, so here this line is going to be is considered as your STL. Okay, so now by using some interpretation keys and satellite images, we can have some plan, or we can have some land use land cover mapping of a particular area. Now in the left hand side you can see this one, you can see satellite images, but in the right hand side one coastal land use map have been prepared by using our own skill. Okay, so then these land use can be used in different issues. Now another example is like it is a satellite image of 2 different years. That is one 2006, and the bottom one is for 2017. Here what I want to tell you that here in the 2006 you can see in Malad Creek, here some sorts of vegetation is there. Okay, but in 2017 you can see there is a damage, there is a degradation in mangrove. So what I want to tell ki by using different temporal data set, we can know that like in these 10 to 15 years, or nowadays in Landsat 2000 in 1973 to now to till date, we are in a position to get the satellite data. So we can plan that earlier this was the situation and now this is the situation. Okay, so this way this satellite image or geospatial technology is very beneficial. Now here I have given some slide related to coastal disaster. I am not going to in detail, but as I belongs to Odisha, and I have given, and Odisha and West Bengal, these 2 states are very, and Tamil Nadu also, these states are very most of the time they are being hit by different tropical cyclone. Here by using geospatial technology, we are in a position to know the exact path of cyclone. Here you can see this is the path, and this is the path. So this is the prediction that in this area are going to be hit by the cyclone, and we can have some vulnerable area zonation that can be thought here. In I have taken this from ISRO actually Bhuvan website. Okay, then here as you know that in Odisha state is very prone to different cyclone particularly. And now in Odisha, what happened, the Odisha State Disaster Management Authority OSDIMA, they have developed multiple purpose cyclone shelter MCS are there. So it is like more than 800 cyclone shelters. Here you can see it is a cyclone, and also it is used for flood also. they have developed this. So during cyclone and also during flood, the people can be taken here as shelter and they are safe here. So this is a very series of multiple cyclone shelter and multiple you can see flood shelter. This is a very good initiative taken by the government of Odisha. Okay. uh, Here by using geospatial technology GIS, here I have given one example, flood hazard zonation. So during different flood timing, we are in a position after the flooding we can have some zonation that these area are very prone to your flooding, and this is high level high, this is medium, and this is low. These sorts of classes can be done by using geospatial technology. Now, a very informative thing is that our Odisha state, the Honorable CM, he has inaugurated the coastal hazard map in the year 2018 with the collaboration with ISRO. Here, the total atlas is prepared for the entire coast of Odisha. Now another slide is there. Here you can see that it is from ISRO. Actually the source is ISRO. Here you can see in the year 2017 almost 8 states, okay, 8 states they have experienced different type of flood and cyclone, but in 2018 it is 10 states are there, and district you can see 112. In 2019 again it is 14 states are there. So in 2020 you can see states are 15, they are experiencing the flood and cyclone and some other natural disaster. So what my point is there, nowadays the occurrence of cyclones and flood is increasing very day by day, so the use of geospatial technology is also increasing very rapidly. Now here one example is there, the disaster and its phases. So now you can see that some 4 phases of disaster management is there. Like we need to prepare before the disaster, like we have to respond, particularly this for your cyclone, we need to have some quick response, we need to have some we have to recovery, and also we have to go for some mitigation issue. Okay. Here I've tried to give some example of how space-based inputs or these satellite images, they are useful for this coastal disaster issue. Now, space-based observation can contribute to a lot of disaster measurements, cycle like prevention, preparedness, early warning system, EWS. There, early warning system are there. All the things can be undertaken by using geospatial technology. In my last part, actually, I've taken this land use land cover dynamics from the this Bhitarkanika area. Here you can see the land use land cover mapping of 1973 by using the your Landsat imagery, then 95 and 2017. In why I have taken this, because in this analysis you can see that in the year 1973 the vegetation was like 22.74%, but in 2017 you can see it is reduced to 18.05. That means there is a rapid degradation of your vegetation cover. Along with that, the settlement was 2.90%, but it is increased to 6.74. So there is a rapid you can see degradation of vegetation cover, along with there is an increase in settlement. Here another vegetation vigorous dynamic is given here. The NDVI for the year 73-85 to 2017. These 5 data sets have been analyzed, and the your result is there. Like earlier I was telling in my land use class also, there is a decrease in vegetation. Here also you can see that uh, in the year 1973 the dense vegetation was like 35.23, but it is decreased to your 22.43. So it shows that the coast is under very severe pressure. So as a coastal manager or a decision maker, we need to use the geospatial technology in a very optimum level, so that the coastal issue can be solved, and we can have the sustainable development. Thank you very much. And if you have any query or issue, then you can ask me.
If any of the participants have any question, you can ask those, or you can write in the chat box as well.
I think there is no question. Yeah.
Yes, I also think the same. There is no question raised. Thank you so much, sir.
Yeah. Thank you.
We have come to the end of our session, nearly end of our session. But before that, I must mention our deepest sense of appreciation to Dr. S. Hajra, Dr. S. K. Das, and Dr. Rajiv Ranjan Thakur for giving an excellent coverage to their topic in this short span of time. It is our privilege that learned person like you all have accepted our invitation and shared your thoughts and through such instructive presentation with us. Thank you so much. And I cannot thank enough to Professor Surya Prakash for joining us today and always supporting us. So, with that, we have come to the end of the first day of this 3 days online capacity building program on coastal disaster risk reduction and resilience. On behalf of my institution, I'm compelled to all the esteemed delegates and speakers and each and every one of the participants who have joined us today. Hope you like today's session and also join us tomorrow at 2:30 p.m. sharp. So one last time, thank you all. Thank you for joining us today. Hope to see you all tomorrow. Thank you. And we have posted the attendance sheet in the chat for the feedback link. Thank you.
ಇದು ಏನ